Hello and welcome to the Omnex webinar, Automotive Cybersecurity Integration with Functional Safety and ASPICE. Today's presentation is being conducted by Dr. Juan Pimentel. Juan is an Omnex consultant with extensive engineering, safety, and cybersecurity experience. He has extensive experience in security and cybersecurity in operational technology, industrial control system environments, and including oil and gas, petrochemical, and automotive. Go ahead, Juan, you can start the presentation.
Okay, good afternoon, and thank you for joining this webinar on Automotive Cybersecurity Integration with Functional Safety and ASPICE, organized by Omnex. My name is Juan Pimentel. I'm a principal consultant here at Omnex. So first of all, a few words about Omnex. Omnex was a company that was founded in 1985, and the initial specialties included quality, but lately we have been expanding with functional safety and cybersecurity. So Omnex is headquartered in Ann Arbor, Michigan, and we're a global company. We have offices in many countries and offices around the world, particularly in Asia and Europe. And with the consultants have worked on standards like quality, safety, and cybersecurity, as I mentioned. And we currently support several tools, for instance, FMVEA, ASPICE, MSA, and lately we're adding tools regarding to functional safety and cybersecurity. As I mentioned, we have offices in many parts of the world. I think you could see some of the offices in this chart here, particularly in North and South America, Europe, and Asia. So in this webinar, I'm going to be talking about some current issues in cybersecurity, given that the standards are fairly new or still in development. And also, I'm going to concentrate on the topics of integration. My background basically is that I've been a consultant with Omnex for almost a year now, but I've been doing consulting in other industries in the past. And I used to be a professor at Kettering University for a few years. I have done some previous work with cybersecurity and functional safety in several industries, particularly with oil and gas in the Middle East. And needless to say, I have worked a lot with automotive systems, applying both safety and cybersecurity. And part of the work that I'm doing with Omnex right now, in fact, is to apply my experience and knowledge of cybersecurity to automotive systems, particularly electric vehicles and automated vehicles. The agenda is that I'll be talking about some standards for cybersecurity. As I mentioned, I'll be talking about some key issues, particularly with process flow, Terra, and integration, and then an integration issue. This integration issue is very important, but particularly I'll be talking about integrating cybersecurity, functional safety, and SOTIF. And then I'll be talking about some modeling aspects and analysis aspects, including safety, and risk analysis using the FMVEA. And lastly, I'll be talking about integrating ISO and ASPICE, but in addition to ISO 26262, I'll be talking about introduction of ISO 21434, and then some conclusions. So the agenda is to talk about some standards, some issues, as I mentioned before, some integration, and this particular webinar actually will concentrate on the integration. And then some modeling issues. We'll talk about some risk analysis using FMVEA and then integrating 26262 with ASPICE. So this is the current trend in terms of the standards that are applicable to the vehicle. I'm emphasizing ISO 21434 and particularly J3061, but as you could see in this slide, there are actually several other standards that are applicable, particularly at the back end, and particularly what it's called the Intelligent Transportation Systems. These standards called XITSEC. They're about intelligent transportation systems. And other SAE standards, for instance, SAE J3138, which is about the OBD port, and also SAE J3101, which is about the hardware devices in terms of cybersecurity. So as I mentioned before, the primary standard is 21434. And this standard, as a matter of fact, is still in development and is expected to be finished at the end of next year. And the purpose of the standard is basically to define a structured process to ensure that the cybersecurity is applied in the vehicle. Secondly, to reduce the potential for a successful attacks and risk on the vehicle, and also to provide some clear means and nomenclature so that everybody is on the same page in terms of securing your vehicle. There is a companion standard, which is J3061, which in fact has been withdrawn. And the reason being is that it has been incorporated into 21434. And the other reason is that there are some companion standards, actually not standards, but rather guidelines about J3061 called J3061 1, 2, and 3. And I'll talk about this in a little bit. So the structure of the 21434 standard, which is the primary cybersecurity standard, as you could see, is very similar to ISO 26262 for those of you who are familiar with functional safety. Similar, but not the same. As you could see, the top part is about generic stuff. The cybersecurity standard has two more additional items. One of them is called the overall cybersecurity management, which in fact it was in 26262, but the new things is really sections or clauses 6 and 7. 6 are about the management aspects, which is project dependent. And 7 is a new area called about, in the standard, I mean, about the methods for risk assessment. The rest of the standard is very similar to 26262. You have a concept phase, you have a product development phase, and then you have a production and operations and decommissioning phase. Now, the thing about the production decommissioning phase is that it is a little bit different than 26262 in that in cybersecurity, this area is still very important because attacks and threats and vulnerabilities, they never stop. It's an ongoing thing. The other thing that you probably notice, in case you're familiar with 26262, is that the middle section, which product development, does not have a separated sections for system design, hardware design, and software design. But rather, as you could see, you have just one single section. That's a major difference between these two standards. In terms of the current cybersecurity standards, as I mentioned before, in addition to 21434, we have this J3061 that, as I mentioned, the original has been withdrawn, but in its replacement, we have 3 additional guidelines that are in development. The first one on top is 3061-1, which is about defining what is called automotive cybersecurity integrity levels. And this will become very similar to the ASIL in 26262. Secondly, item 3061-2, as you could see, is about security testing methods. As it turns out, testing is very important, not only for safety, but cybersecurity. And as a matter of fact, as you could see, 3061 has 2 guidelines, one on testing methods, which is 3061-2, and then another one, 3061-3, on security testing tools. So these are 2 additional guidelines that will complement 21434. In addition to that, historically, SAE has been working already on 2 guidelines, and they are J3101 and J3138 for the hardware aspects of security and also securing what is called the OBD2 port. This has been projects that have been going on for a while, and I think they don't want to stop them, but rather finish them, and somehow they will be incorporated in the 21434 standard. So the next topic on this webinar is to talk about some of the key issues in terms of cybersecurity that some of the organizations may be facing today. So perhaps your organization is having some of these key issues. So if that's the case, I'd like to hear from you later on in the question and answer section. Or if not, this is to tell you about these issues that many of our customers and organizations are actually facing today. So number one is the fact that automotive cybersecurity is different from EIT, and EIT is Enterprise Information Technology Cybersecurity, and also Industrial Cybersecurity and IoT Cybersecurity. So what I'm trying to say here is that security for information technology has been around for a long time. In fact, it's a 40-year-old business or technology, if you will. It has been around a long, long time. I'm talking about protecting just PCs, IT systems in general. The next newer thing that happened historically was industrial cybersecurity. Again, the industry has about 20 to maybe 15 years of experience in industrial cybersecurity. By industrial, I mean process control systems, field bus systems, and this is something that's being used in the Middle East a lot in terms of oil and gas that I mentioned earlier. And then you have IoT cybersecurity, IoT meaning Internet of Things. And again, people have been working on this topic for about 8, 5, 6 years at least. So the point is that automotive cybersecurity is actually the new kid in town. It's very new if you compare to enterprise IT security or industrial cybersecurity or IoT cybersecurity. And the difference is in terms of many things, particularly in the area of threat models, attack surfaces, attack vectors, vulnerabilities, cybersecurity controls. What I mean is that all of these particular topics are quite different for these particular fields. In other words, just because EIT has been around for 40 years, it does not mean that you could apply the same threat models, the same vulnerabilities, or the same cybersecurity controls, because they are not the same. They're totally, totally different. So it's almost like in automotive, we're beginning with a clean slate in terms of these things. Another issue is, issue B here, is implementing what is called secure by design. Secure by design is being promoted by many standards organizations and even industrial organizations, OEM suppliers, because it seems to be the best bet for all organizations to solve this problem. And what it means is to use, as I said, best practices. And also the issues involved is solving things like to have a clear and suitable flow of what is called cybersecurity processes. These standards really talk about a bunch of processes, not just one, but we're talking about lots of them. And that's not clear for an organization. Secondly, you need to develop a clear management structure. The standards actually help with that because both 26262 and 21434, they're really management standards for safety and cybersecurity that tries to guide you how to implement the technical aspects, but at the end of the day, they're really management standards. And then we're talking about the fact that we have several standards and guidelines that actually are not very explicit and clear about many of these things. As you saw in the previous diagrams, in fact, 21434 and J3061 are not the only guidelines or standards. There's a whole bunch of them from ISO, from NIST, from even the European Community, and from other ISO standards relating to ITS, which is Intelligent Transportation Systems. In other words, that is some of the, in fact, main issues that the standards developers are facing today, how to integrate a bunch of somewhat dissimilar standards into one coherent standard. And therefore, you can expect to be some confusion with some of these standards. So for instance, this is one example. We're talking about controls on the right. We have all kinds of controls and try to correlate those to main areas of security. You're talking about predictive controls, deterrent controls, preventative controls, detective controls, and so on and so forth. And how do they relate to the major security areas such as threats, vulnerabilities, incidents, assets, and things like that. In terms of the process flow that I mentioned before, this is the process flow for 21434. And as you could see, there are many processes. Most of them are actually listed on the left side. And on the right side in green, I tried to put some of the outcomes or work products, as it's called in the standard itself. So as you could see, we begin by an item definition that leads to performing a TARA. Well, I'll talk a little bit about TARA in a little bit, but TARA is a major step forward in this whole process. From the TARA, you derive what is called the top-level cybersecurity requirements that will actually guide through constructing what is called a preliminary architecture of your system. And that will drive the rest of the development. That will go down into developing what is called the cybersecurity concept. And for those of you who are familiar with safety, in safety we have a similar concept called safety concept, functional safety concept. So many of these processes and ideas from cybersecurity have a counterpart in safety, but it's not 100%, so you have to be careful about this. But for the most part, most of the concepts or ideas are really the same, and there are some differences, of course. So following down from cybersecurity concept, you go what is called a refined architecture. In safety, they call it technical architecture, functional technical architecture. And then you continue down with vulnerability analysis, and that will lead you into your requirements at the design level, at the system level and design level. From there, you proceed to design the system at the system level with requirements that will flow down into two areas called hardware and software. And then, of course, you proceed with the hardware and software design and worry about verification assessment activities. And finally, talking about integrating and testing. However, in this particular area of testing and integration in cybersecurity, there's an important topic that needs to be considered throughout, which is the topic of vulnerabilities. You still need to worry about those and in fact talk about testing methods. So penetration testing is one of probably the best methods in terms of do the testing. So that's included in an additional outcome here. And finally, you come up with what is called cybersecurity case, and that will lead you into a release for production. In terms of TARA, what we have is basically major steps, including attack visibility, doing a risk evaluation, and finally determining the risk level. In cybersecurity, unlike safety, in fact, this is an area where it's not totally understood. Currently, we have two levels of security. One is called CAL, which stands for Cybersecurity Assurance Level, and the other one is called Risk Level. Think of CAL as being a approximation at the course level, very broad, simplification, if you will, of risk levels that will guide you through the design process with some aspects of the design process. However, in order to really come up with a fine-tuning, particularly for controls, you need to take a look at what is called the risk level. And there are techniques to obviously evaluate these levels. We will clarify these techniques in a little bit. For instance, I have here some extracts of Excel data sheets that we use with some of our customers to do what is called the CAL determination on the top and then the risk level determination on the bottom. So the CAL determination is simpler. CAL on the column here, which is cybersecurity assurance level, depends only on two things, which is the exposure and the impact. And to do the impact, you basically try to estimate the consequences of a attack moving forward. So in this case, our example is for an airbag system. The operation situation is on highway driving. We analyze a threat mode. In this particular case, the threat mode is an unintended deployment due to a cyber attacks of the airbag systems, obviously. So in this particular case, the threat effect is pretty severe, or injury, maybe even death, and the impact is 3. In terms of exposure, we're talking about a medium type of exposure for this particular threat cause, which leads us to a CAL level of 4. Now, in terms of the risk level, as I mentioned before, it's an F. It turns out that depending upon the model that you adopt, the levels are not the same. There are several possibilities for the risk level. This is one example that uses letters A, B, C, D, and F, but there are other models that do not use letters. They use words like critical, medium, low, and things like that. But in this particular chart, as you could see, the risk level, which is a letter, depends on 2 things: attack feasibility and impact. Impact is similar to the CAL determination, but the attack feasibility is a bit more detailed estimation of that. And that is shown in this lower section of the Excel datasheet. So the attack feasibility is right here. The rating is high, and that is because of the attack path and the vulnerability and the threat scenario that was chosen for this particular threat. So as you could see, there are some techniques to determine both CAL and risk level. Just emphasizing the fact that CAL is a approximation to the risk level. The risk level is a bit more detailed, and there are many techniques to actually evaluate the risk level. This is only one of the techniques that is being promoted by the standard, but others are possible. Again, following the key issues currently in the industry today, I like to go over issue C here that has to do with standards. I already mentioned that ISO 21434, which is expected to be the major standard for cybersecurity, is still in development. It's not finalized. And we expect that there will be several guideline standards in addition to ISO 21434, particularly the guidelines related to J3061, number 1, 2, and 3. We mentioned those before. In terms of implementing these standards actually deal with 2 major things. Number 1, processes. And these processes are mostly management processes. And these standards do a great job in managing these particular processes. But there are other processes that are more technical in nature. And unfortunately, the standards are not designed to deal with this explicitly. They only mention them implicitly. So it's up to the organizations to actually become aware that there are technical processes that are not detailed in the standards, and they're supposed to be responsible for themselves. Moving on to another issue here, issue D, which is about achieving appropriate level of defense and protection. Again, this is something that the standard 21434 just mentioned, that something that you have to do, but they don't tell you the actual techniques, the actual technologies or state of the art on how to do this. Perhaps they do mention some techniques generically, but they don't actually go into the details on how to apply those techniques. And this is something that I mentioned before, for instance, in the area of threat analysis or threat models. There are so many threat models out there that a organization in the automotive industry can use, and it's not very clear cut today which one is the best. So this is something that you need to do a little bit of research on your own and actually decide which one of these threat models will be the most applicable to your organization. And actually the same thing goes for security controls, for vulnerability analysis, for penetration testing, and then techniques that have to do with defense and protection. And these techniques, by the way, they're particularly important for the phase related to operations, maintenance, and decommissioning. And this is unlike safety. In safety, once you go to these phases of operation, maintenance, and decommissioning, there is not much you can do in terms of ongoing protection, if you will, about safety, because it has been done in the past, or I mean previous, in the prior phases. So in this particular phase of operation, maintenance, and decommissioning, in the case of safety, it's pretty much static. But in the case of cybersecurity, it's highly dynamic. It's still going on. You still have to continue doing this type of work. Moving on to issue E here, key label E, have to do with integration of standards and tools. And actually, this is a major section of this particular webinar about integrating, particularly integrating standards and related tools. And I'll be talking about in a bit more detail about this in a little bit. But the fact of the matter is that many of our customers and many organizations are really investing a great deal of effort and money on safety standards like ISO 26262, and then the upcoming SOTIF standards for safety, and also with ASPICE, which is related to the software aspects of automotive systems. And now we have a new standards to worry about, which is ISO 21434. So the question is, how are we going to implement this in a very effective and efficient and cost-effective manner? And Omnex is promoting an integration of these standards. And the major reason for that is that it enables to use less resources and to lower the cost of your standards, not only implementation, but actually activities such as auditing and assessments. So this is a slide that explains the relationship of ISO 26262 and ISO 21434, in other words, safety and cybersecurity, how they're correlated, meaning that you could actually perform the integration fairly easily, as you could see. The diagram that you see is the famous V model from functional safety. And on the left side of the V model, as you probably know, we have requirements flowing down all the way from the concept phase to the requirements flowing down to the design phase and the implementation. And on the right side, you have items such as integration, validation, and production. So testing is on the right side, and requirements flow down is on the left side. And as you could see, in the case of safety, you do what is called a HARA, which is a hazard analysis and risk assessment, which is correlated to TARA in cybersecurity, which stands for threat analysis and risk assessment. Conceptually, those two activities are really the same, and this is why they're drawn here on the same level and correspondingly, except that HARA obviously deals with safety aspects and TARA deals with security aspects, particularly threats. And there is a correlation between those two. And eventually the correlation will be that we will be talking about correlating ASIL levels, which is a set of levels to measure the risk levels in safety, together with AXILs. AXILs is a new term for cybersecurity, which stands for Automotive Security Safety Integration Levels. We're talking about security integration levels in this case, actually, not safety. So this is automotive cybersecurity levels that corresponds to automotive safety levels on ASILs. From there, you actually move down to the requirements in terms of safety and security, of course, and then start your design process, beginning with the safety requirements or security requirements, flowing down into the design details into hardware and software aspects, moving down to the implementation. And then on the right side, after you finish your implementation, you need to start testing at the unit level and then at the system level. And this is the area where, as I mentioned before, testing is particularly important for cybersecurity. As a matter of fact, the new guidelines from SAE, which is J3061, 1 and 2 and 3, have to do with testing aspects, primarily testing aspects. Just pointing out the fact that testing is particularly important. And then moving up, as you could see, go through the validation and then the final ending with the production system. In this particular diagram, I'm going to actually show a bit more details as to the integration of cybersecurity, functional safety, and SOTIF, as I mentioned before. So this diagram, in fact, the original diagram came from the SOTIF standard, which is ISO 21448. And as you could see in the color diagram here, the stuff in gray is 26262. The stuff in light brown, I believe it is SOTIF. And then I will superimpose in a little bit some activities that relates to cybersecurity. But this diagram, in fact, shows that the activities of safety and functional safety and SOTIF could be integrated, as you could see here, because they're both dealing with safety issues. So let's talk about how this can be integrated with cybersecurity. First of all, in cybersecurity, which is stuff in blue, the item definition is done at the same level, and it's pretty much the same idea. Secondly, you do a TARA in conjunction with the HARA. And then you do what is called the cybersecurity concept, which is in conjunction with the safety concept. And then you move down to what is called the refined cybersecurity concept, which is related to the technical safety concept. The hardware and software development is identical, so that is not shown explicitly here. And then moving up on the right side of the B, you have the testing going up to the assessment level, which are performed similarly. So at the end, on the top right here, you have the fact that you have to do a cybersecurity assessment, just like you did an assessment at the safety level. So therefore, as you could see in this particular diagram, you show that it is possible to integrate functional safety, SOTIF, and cybersecurity in terms of the V cycle of the system engineering model. However, there are other types of integration that you can do. And this integration that we're talking about in the next few slides is about integrating models. I talked about threat models in the past, I mean a few slides ago. That's very important. And the fact of the matter is that we have two types of models. The one on the left talks about safety, and the one on the right is about security. And then when you do HERA, you have like techniques like HAZOP, FMVEA, FDA. And then if you do TERA, you have techniques such as Octave, Stride, HTMM. However, it turns out that if you want to do an integrated safety and security, you have to have models that actually incorporate those two things, either simultaneously, or at least the modeling structure allows you to incorporate those somehow. And this is what we're talking about here in the middle as an intersection of HARA methods and TARA methods. In terms of the common techniques, you have models such as HEAVENS, EVITA, SAHARA, and FMVEA. In addition to that, you have frameworks that actually could allow you to combine safety and security in a more holistic fashion. And they're CORAS, STPA, SafeSec, and SGM. In this particular webinar, I'll mostly talk about FMVEA and actually have a few comments about these other modeling methods. So this table has a list of some of the most significant threat models that is applicable for automotive, number one, because I mentioned before that there are many methods that are not applicable for automotive. And secondly, they actually integrate safety and security. So you're talking about Sahara, FMVEA, VITA, and Heavens. Most of them actually are based on, as you could see, on Stride, which is a major model developed by Microsoft that allows you to actually classify threats. So threat classification is one of the basic things that you do. But in addition to threat classification, you need to do threat modeling and risk assessment. So a few comments about these particular models. Some of them have their pros or cons. There is no an ideal thing as an ideal model because it changes. But it turns out that FMVEA is one of the models that I particularly like because it has a focus on safety, and yet you can actually use that information to do a you could use prior developments or results from threats analysis to actually do a combined safety and security analysis of the item that you're talking about. So as I said, I will give you a bit more detailed information on how to use a FMVEA. I mentioned that there are other more generic approaches such as CORAS, STPA, SEC, and SGM. As I mentioned before, I will not go into great detail about these because these are a bit more sophisticated, and the reason is that they allow you to actually do both simultaneously. Whereas the method that I'll be talking about, which is FMVEA, allows you to do one, but taking into account the other one. In other words, you concentrate on threats and taking into account the safety aspects of your threat analysis. So this particular slide shows one depiction of one method that combines safety and security. As you could see on the top side of this picture, you do a traditional HARA, which is hazard analysis and risk assessment. And on the bottom, you're going to do a threat analysis. So you proceed up to a point where they allow you to combine the hazards with the threats and then end up with a comprehensive threat list so that you could do your risk assessment. Such risk assessment then will allow you to take into account both hazards and threats in an integrated fashion. Let me talk about now how you can perform what is called a FMVEA. As you probably know, the FMVEA is a technique that has been used for a long time to identify hazards in the case of safety analysis. And obviously it can be used also to identify threats, but this particular one is a combination, which means that you could do both. You could do a identification of threats and hazards at the same time. And basically the idea is that it follows a cause-effect type of relationship. In other words, the cause in this case is a failure in the case of safety and a threat and vulnerability, or both in the case of security. And then that results in what is called failure mode or threat mode. And those could be incorporated to analyze the effects on your system. From that, you go into analyzing the severity of those effects. And then finally, you try to estimate the probability of that happening, which will result in a criticality factor. And that will be an input to the final FMVEA analysis. So I have one example to show the details about that, but this is the flow diagram that would use for a FMVEA. This flow diagram, as you could see, is basically a repetition of the safety case, which is on the left side here about failures. We pretty much try to emulate that on the right side for the case of security. And obviously, in terms of failures, we talk about threats. And in terms of failure mode, we talk about threat modes and so on and so forth. So by the time we're done, then we have hopefully incorporated all the failure modes and all the threat modes to come up with the risk factors for this particular item. Let's work out a quick example about this. And this example assumes that I have a so-called measuring device with two interfaces, one to a cellular system, to a backend system, and the other one is through a local HMI. This particular study was taken from the literature, it was not mine, of a system that's applicable to oil and gas systems, where you have a measuring device, the private network is a field bus, and the public network is GSM. However, in the case of automotive, this is very similar to a entertainment system here, where the measurement device could be all of the sensors associated with maybe RPM, temperature, and stuff like that, that goes into the head unit of the vehicle. The local HMI would be the display, actually. And the backend, obviously, is a backend system, but instead of GSM, which is a bit dated, this technology would be cellular, G4 or G5 technology. So this is very much similar to an automotive system. And let's talk about the details of this FMVEA analysis done on this system. We analyze a threat classified in terms of STRIDE, which is spoofing of identity. So as you could see here, threat 1 and threat 2 here is we're talking about two vulnerabilities. One, the one on top, we're talking about no device verification, man-in-the-middle attack. And the one in the bottom is about actually an attacker pretending to be the measuring device. We have the corresponding threat effect, the system status, the system effect, the severity, the system susceptibility, which was defined in one of the prior slides. You could take a look about that. And finally, talk about the attack probability. The attack probability is one of the main components in order to determine the risk level. But in this particular case, this is the end result of this FMVEA, the attack probability, and actually to identify this particular threat for this particular situation. So as you could see, this is a generalization of the well-known FMEA tool or technique to incorporate vulnerabilities, and this new method is called FMVEA. Next, I'd like to talk about another type of integration. This integration is integrating ISO 26262 and ASPICE. The main motivation for this is that organizations are actually investing a lot of effort and money into obviously implementing 26262 on the one hand, and also implementing ASPICE on the other hand. And the question is, how about if you could combine this particular implementation into an integrated implementation? And in fact, this is happening today by some organizations with good results. And there are two possibilities here. You could actually put ASPICE into 26262 or vice versa, put processes from 26262 into ASPICE. The method that I'll describe in the next few slides is the latter one, meaning that we're basing our integration on ASPICE because it's easier to do it that way depending upon the modeling structure that you use. So the assumption then is that you have, as you know, ASPICE define many areas, and each area many processes, and I'll show you that in a little bit in the diagram, what's the main idea about this integration. So ASPICE is based on a process reference model with details how you're going to qualify your implementation, and then a process assessment models where you define all of these various processes that we're going to analyze. And then when it comes time to actually do the assessment, you obviously define your purpose, scope, constraints, and then worry about your assessor and the capabilities of that. at the end of the day, when you perform the assessment, you come up with capability levels for your particular process. However, there are many processes that you can do, and the standards is a bit complex about that because it includes many processes, and that is clarified in the next few slides. However, before I do that, the main idea, as you could see here, is that in addition to the standard process reference model, we incorporate models from ISO 26262 on the top side, which means that we're going to do some safety extensions so that we could perform the particular analysis on those processes from the safety point of view. On the lower side, obviously, we need to include a competence about 26262. This is the original diagram that shows all of the processes that SPICE is concerned about. And as you could see, as you probably know, if you're familiar with ASPICE, you have several groups. On the top left, you have the acquisition process group, down the supply process group. In the middle, perhaps the most important ones are the system engineering process group and then the software engineering process group. Below at the bottom in green, you have the support processes group. On the right side, you have the management, reuse, and process improvement groups. So all in all, as you could see, you have many processes here that you have to worry about. In practical implementations, typically you not implement all of them, maybe about half of them typically. But what is the idea? The idea again is to supplement all of these processes in the original ASPICE with processes that come from ISO 26262. And if you do that, you will come up with a revised set of processes. And I'm not including, because of lack of time and space, all of the details, and I am only including two process groups, the system engineering process group and the hardware engineering process group. I should emphasize that there is no counterpart of the hardware engineering process group that I'm including here in the original ASPICE, because original ASPICE does not have a hardware, rather software. However, the standard does allow for incorporation of additional groups. So this is in accordance to the ASPICE standard. So basically the stuff in dark gray here is totally new processes that was created so that we could incorporate ISO 26262 onto the original ASPICE standard. And the items in light gray are modifications of a process that's defined already in ASPICE to accommodate the requirements of ISO 26262. So in a nutshell, what you have here is a streamlined process, either by accommodating the original process in light gray or actually incorporating brand new processes, which is in dark gray here, so that we incorporate the processes from ISO 26262. The final structure then would be something like this. As you could see, what I have done here is incorporated the original ASPICE, and then in light gray, I incorporated some ISO items that you need to take into account from ISO 26262 for functional safety. And in blue, dark blue, from ISO 21434, which is cybersecurity. So in a nutshell, this diagram is basically a summary of the main ideas on how to do the integration. The details of the integration, of course, is a bit more complex than this, but this shows the main idea on how to perform the integration, which is basically to say that we use the same ASPICE processes, and on top of that, we're superimposing processes from or to meet requirements from ISO 26262 and from ISO 21434. If we do this, the bottom line or the end result is that we do have an integrated approach to integrate functional safety, cybersecurity, and ASPICE. And this brings me to the main conclusions of this webinar. And at the end of these conclusions, there will be some time for some question and answer period. But the main conclusions that I have is the following. First of all, we have that ISO 21434 is really a process-oriented, risk-based cybersecurity standard, very similar to ISO 26262, that unfortunately is not fully developed yet, but it will be in the next few months or next year sometime. However, it does not mean that you cannot start doing work in this area, because you could use the guideline J3061 to guide you in the process, because some of these management processes are really similar. Secondly, as I mentioned before, J3061 has been withdrawn, the original one. And in its place, we have additional ones that are called standards that will clarify the issue of seals for cybersecurity, and then the issue of testing, which is very crucial, either testing methods or testing tools. And that's in J3061-1, -2, and -3. Another major conclusion is that although the final standards are not ready, Omnex recommends that organizations start now with, for instance, training and to formulate what is called an implementation plan. And we can guide them through that process. Still, another conclusion is that there are many key issues that still need to be overcome. Implementing these standards is not very straightforward. And even for the developers of the standard, it's not very straightforward to come up with a streamlined standard that, in fact, has to work together, as I mentioned, with other guidelines, other standards that deal with similar aspects in other areas. In other words, J21434 is not the only standard around. It has to be compatible, and it has to be integrated with other standards. And I'm not talking about safety standards or quality standards. I'm actually talking about other cybersecurity related standards. And that is one of the main issues of the developers of the standard, actually. Also, I mentioned that there are many threat models, and there's still new ones coming up. And traditionally, the enterprise IT cybersecurity have many models. Unfortunately, not all of them are applicable for automotive. In other words, it's a little bit challenging to actually decide what threat models are really applicable for your organization. Another thing that we talked about is FMVEA and how that enables the integration of hazard and threats. I went through a fairly detailed example on how to do that. And then the last portion of the webinar talked about integrating 3 particular standards that are very important for our customers, and they are safety, ISO 26262, the cybersecurity, which is ISO 21434, and ASPICE. And I mentioned, in fact, with a diagram that it is possible to integrate all 3 of them if that's what you desire. And in fact, Omnex recommends that you start moving into that direction. And then, of course, we have new models and tools that are becoming available, not only for the integration process, but even for modeling aspects. I clarify some of the models that is being used today, and there are new ones coming up. So along with that, I'm going to actually show you some of the stuff that Omnex have in terms of training, in terms of other services that we can provide. First of all, we provide services in the area of automotive SPICE. As you could see, we have courses, we have the possibility of doing some consulting in this area. In addition to that, we have ISO 21448, even though it's a new standard, but we're developing a course around that. And then on the Agile series. In addition to that, we have a broad curriculum in terms of ISO 26262. We have many courses and related consulting activities in this area, as you could read here. And obviously, for more additional information, you could go to our website and find out more details about this. The ISO 26262 is fairly broad. This is the second page of that, showing some of the new courses that we're coming up with that you might be interested in the near future. And then, of course, the Cybersecurity Series, which parallels somewhat the functional safety series, but obviously for the area of cybersecurity. Again, we have several courses that are either available or will be available pretty soon. And we also have a series of generic courses, generic areas, such as an introduction to systems engineering with a safety and cybersecurity perspective. Also an introduction to autonomous vehicles and automated driving or autonomous vehicles with a emphasis on functional safety, SOTIF, and cybersecurity. And then there is also a generic course on information security. In addition to that, we have enterprise software that we offer to our clients. As you could see here, this enterprise software is primarily quality management. However, we're incorporating functional safety on top of that. And the plan in the future is to incorporate cybersecurity. So these are some of the software tools that I encourage you to take a look at in more detail in our website, and also some additional services. In fact, we have services in the area of consulting, as I mentioned before, in terms of systems, in terms of plant tech, which has specialized services, primarily for auditing, project management, and outsourcing. And finally, as I mentioned before, training. We do training on-site and at the customer facilities. In addition to that, we have e-learning and webinars such as this one. And finally, we have a solution that is at the enterprise level, again, emphasizing several standards, in this particular case, APQP and functional safety. In the future, we expect to expand this to cybersecurity, of course. So we're talking about integrated management of APQP, management the customer requirements, manufacturing controls, linking FEMAs with test plans, managing the whole process, managing some particular information about your facilities, your process, basically MSA and stuff like that, and then conducting integrated problem solving courses or workshops, and then top management for some of these tools. So with that, I'm going to end this particular webinar. I believe we're on time. And also, we do have some time for some of the questions that you may have about this. So with that, on behalf of Omnex, I'd like to thank you for your attending this particular webinar, and I hope this will be of a benefit to you and your organization. Thank you.
Hey Juan, one question we have here is there a particular order that people should be implementing these standards for most effectiveness?
Oh yeah, that's a great question. Yes, in fact, the natural order is to start with a quality standards, even though this webinar was not about quality, but you should start with quality and then move on with either ASPICE or functional safety. Perhaps ASPICE will be the next one because it's generic software, and then specialized software like software that goes into safety and cybersecurity. And then follow that with safety, which is a more established standard and more mature standard, given the fact that the first version was published in 2011, the second version 2018. And then the cybersecurity standard 21434 should be the last one, only because it's a brand new standard. However, it does not mean that you cannot begin doing the work right now. You could begin with just the old, even though it has been withdrawn, but the SAE J3061 is a very good guideline to really go by today. So hopefully that answered the question.
I think it does. Another question we have is, Is there a particular course that Omnex does that's a good start to understand cybersecurity? How does someone dip their toes in? It's kind of that type of question. It's a good introductory course.
Yes, again, that's a great question. Omnex does not have a introductory course in terms of the technical side. We do have courses around the standards themselves. And we have three, you probably saw in the lineup of courses, but I'm going to be talking about particular three types of courses, okay? One that is a one-day course, which is a summary overview, but unfortunately it's only for managers, it's not very technical. However, it does cover the fundamentals of cybersecurity in a very simple fashion. And as I said, that's an overview for managers. And then we have a two-day type of an engineering summary of the whole standard. And then we have the 5-day, which we call certification, that we actually go into great detail about the standard. Again, these courses are not primarily technical. Obviously, there are some technical aspects, but primarily they're concerned about the standard itself, which is a lot to do with management. I would say that these courses that I talked about are probably 80% management, 20% technical. Now, we do have in development other courses that are probably the other way around. Let me mention one, which is already finished. It's called a Terra course. It's a course on Terra. So this particular course is 80% technical and 20% management. It's backwards. So I hope that answers the question.
I think it does. That is the last question we have. So with that, we should conclude this webinar.
Okay, great. Then on my behalf, this is Dr. Juan Pimentel. I'm a principal consultant at Omnex in the area of cybersecurity. And I appreciate whoever attended this webinar. And I also appreciate the questions that were asked. And I hope that this particular topic has been of benefit to you. Again, if you have any questions, email Omnex, either on the contents of this webinar or particularly on, we will be very much interested in learning from you about future topics for additional webinars. Thank you so much and goodbye.